Here we have a SAT map question. Okay, let's go with the information. Here we have a piecewise function that is f of x equals to x positive 2 if x is greater than or equal to 0, and f of x equals to x negative 2 if x is less than 0. The function f is defined above. Which of the following cannot be f of x for any value of x? Okay, among the given answer choices, we have to find the one which cannot be the value of f of x. Okay, to solve this problem, what I'm going to do is I'm going to draw a real number line first. Let me draw it. Okay, now let me mark some numbers over here. 0, 1. Let me do it. So here we have 2, 3, 4, and it keeps going. Let me do it. And on the left side of 0, we have -1. We have -2. Here we have -3. Here we have -4. Okay, now let me consider the first of here, that is, the first piece of the given function x positive 2 if x is greater than or equal to 0. X is greater than or equal to 0 means like we have taken a filled circle over here, because x can be equal to 0 or it has to be greater than 0. So we have to draw a line to the right side of 0. Okay, now let me take the second piece of the given function f of x, that is x negative 2 if x is less than 0. X is less than 0 means like we have to take an empty circle over here at 0, because x cannot be equal to 0, but x has to be less than 0 means we have to draw a line to the left side of 0. Okay, so for the first one, when x is greater than or equal to 0, the piece we have for f of x is x positive 2. So we can write over here f of x equals to x positive 2. And for the second one, when x is less than 0, the piece we have for f of x is x negative 2. So we can write over here that is f of x equals to x negative 2. Okay, now let me consider the first piece, that is f of x equal to x positive 2 if x is greater than or equal to 0. So here x can be 0 or any value greater than 0. So now let me start plugging in the values for x from 0. So now let me plug in the first value of x, that is 0 for x over here. When I do so, I'm getting 0 positive 2, which is equal to 2. Okay, even I can plug in 0 0.1, 0 0.2 decimal values also I can plug in for x. Anyways, let me consider one of the integer values. So the next integer value is going to be 1. When I plug in x equals to 1, I am getting 1 positive 2, which is equal to 3. Okay, the next integer value is 2. Then when I plug in x equals to 2, I am getting 2 positive 2 equals to 4. When I plug in x equals to 3, I'm getting 3 positive 2, which is equal to 5. When I plug in x equals to 4, I'm getting 4 positive 2, which is equal to 6. Okay, now let me consider the second piece of f of x, that is f of x equals to x negative 2. In this case, x cannot be equal to 0, x has to be less than 0. We can consider like even negative 0.1, negative 0.2, negative 0.3, also the values which are very close to 0 on the left side. Okay, anyways, let me consider only the integer values. So in that case, the first value I have to use -1. If I consider only integer values, in that case, I'm getting f of -1. So that is I have to plug in -1 for x over here. -1, -2, which is equal to -3. Now let me take the next integer value -2, then I'm getting -2, -2, which is equal to -4. Now let me consider -3 as a value of x, then I'm getting -3, -2, which is equal to -5. Then let me consider the next integer value, that is -4, which is equal to -4, -2 equals to -6. Okay, I think the calculations we have done so far is enough. Now we can start verifying the given answer choices. That is, we have to find the one which cannot be the value of f of x. Okay, let me go to answer choice A. We have -6. So I find a -6 over here as one of the values of the given function. So this -6 can be the value of f of x, but we have to find the one which cannot be the value of f of x. Since this -6 can be the value of the function f of x, we can reject answer choice A. And now let's go to answer choice B. We have -4. Here we have -4 as the value of the given function f of x. So since the -4 can be the value of the given function f of x, we can reject the answer choice B as well. Okay, now let me go to answer choice C. We have 3, and we have 3 as the value of the function f of x. So since 3 also can be the value of the function f of x, we can reject answer choice C as well. Okay, now let me go to answer choice D. We have 1. Okay, I don't find one over here and here. And also we can verify with the given functions with the given conditions. So let me take the first piece of f of x, that is f of x equals to x positive 2 if x is greater than or equal to 0. So for any value, so that x greater than or equal to 0, so the value of this x positive 2 will be 2 or greater than 2, as we have discussed over here. So the first piece of f of x can never have a value 1 when x is greater than or equal to 0. Now let me go to the second piece of f of x, that is x negative 2 if x is less than 0. Even if I choose a value to the left side of 0 and also it is very close to 0, for example x is negative 0.1. So and when I plug in x equals to negative 0.1 over here, I'll be getting negative 2.1. If I plug in x equals to negative 0.2, I'll be getting negative 2.2. And when I start plugging in the integers negative 1, negative 2, negative 3, negative 4 in this piece of f of x, I'm getting negative 3, negative 4, negative 5, negative 6. Anyways, when x is less than 0, I'm getting a value for the second piece which is less than negative 2, that is negative 2.1, negative 2.2, negative 3, negative 4, negative 5, negative 6. So all the values I'm getting for f of x are negative if x is less than 0. So there is no chance to get the value 1 for the second piece of f of x if x is less than 0. So the value 1 in answer choice D cannot be the value of f of x. So the correct answer choice for this question is D1.